Okay, now we're recording. Hello there, this is Mr. Roden, and we were going to be getting ready for our test today. And so, yeah, here we go. Okay, so, what? No, it's recording.
It's recording. You're just a liar.
Okay, so let's go ahead and get started on this one. I'm going to get rid of Mr. Roden here because he's in the way. His head's in the way. All right, so guys, so let's go ahead and you guys got to remind me to quit recording this. That's the biggest thing. All right, who's going to remind me to quit recording? Zane? Who's going to remind Zane to remind me? Aaron. Who's going to remind Aaron to remind Zane to remind me? Michael. Who's going to remind Michael to remind Aaron to remind Zane? Helena. Okay. Who's going to remind Helena to remind Aaron to remind Zane to remind Michael? Riley. Who's going to remind? Okay. Can we keep going with this? I don't know if we can. Okay. Who's going to remind Riley to remind Helena to remind Aaron to remind Zane to remind Michael to remind me? Boston. Okay. Then you'll who are you going to remind Boston? Who's the person you have to remind? Okay. Who's going to remind Boston? Owen. Who's going to remind Owen? Colston. Who's going to remind Colston? Gavin. Got it? Grady. Why are you guys laughing? Grady is a perfectly fine name. Okay, Grady. I didn't say. Why do you guys call him Gavin? His name is Grady. All right. Okay. Pull me a Ben. Victim, volunteer, or stick. A victim, a volunteer, or a stick. Okay, who's your victim? Gunner. So Gunner, how do I start this problem? What's the first statement? So 8x minus 1 equals 9x minus 11. And why is that true, Gunner? Vertical angles are equal or congruent. Vertical angles. And all you have to do is write vertical angles. That's all I need. You guys understand that? Okay, excellent job. Ben, victim, stick, or volunteer?
Fancy Aaron. Or Mrs. Aaron. Oh yeah, let's go.
Okay, who is it? Fancy Aaron? Okay, Fancy Aaron. How are we going to do this one?
So I would add 11 to both sides.
If you do that, what do you get?
You get 8x plus 10 equals 9x.
Okay, and what's the reason? What did you just do?
The subtraction thing of equality.
Well, did you subtract or add?
Addition thing of equality.
Yeah, you added, right? So addition property of equality, right? Okay, Ben, keep going.
Okay. Sylvia, finish problem. So now we need to subtract 8x.
Yep, so what do we get?
10 equals x, and that is the subtraction property of equality.
Sorry. Subtraction property of equality? Excellent. Nice. We're done? Is that right? Connor, how'd you do it? Did you do the x's first? That's fine. Yep. Okay, any questions there? Okay, next problem is 8, right? Okay. What?
Can I make this problem number 8?
Ben, what number do you want this to be? H. We're gonna call. If you want to call, Ben wants to call H. If you want to put 8 in parentheses so you can decode that. There you go. Okay, here's the deal. You write down as much as you need to help you understand. So what is the slope of a line perpendicular to a line whose equation is 2x plus 3y equals -3? Okay, so I'll let you guys write down as much as you need. Remember, this is a study guide that you can use on the test, so you might want to write as much wording down as you need to understand what the question is asking. So this will be, I don't know, Ben will decide who does this problem. Okay, Ben, victim, stick, or volunteer? No, we don't have to do statement reason on this one.
Do the problem right now.
Okay.
The whole thing.
Mr. Zane, how are we going to do this? So we got this word, this funny word here, perpendicular. So Zane, I'm just going to ask you one question. What is the fact about perpendicular lines perpendicular to each other? Opposite means different sign. Very good. So guys, remember, and you might want to write this on your, just for notes, perpendicular slopes are opposite. Does opposite have two P's or one? I can never remember. Opposite reciprocals of each other, right? So you change. So the what you change sign and flip. That's kind of how we'd say it, just kind of in everyday language, right? Change sign and flip. So that's the key to about perpendicular slopes. You guys understand that? Change sign and flip. Okay. So Ben, victim, stick, or volunteer?
Mr. Ethan, you're going to finish out the problem directly now.
Now, Ethan hasn't been here, so Ethan, if you want to try, Ethan, that's fine. What do you think? No? All right. Ethan just wants to take notes and take this in because he was gone for some of this. I don't blame him. Okay. All right. Ben, so.
I'm gonna have Mr. Owen.
Thank you. You're the best.
Okay, Owen.
Okay, so what I did. Wait, where are we?
Well, we need to get a slope, right? A perpendicular slope.
I said first I subtracted 2x.
So you're taking, what do you, so you have 2x plus 3y equals negative 3, right?
Yeah.
And so what's the kind of general strategy you're doing here?
I did the subtraction property of it.
Okay, so yeah, so you're solving for y, right?
Yeah.
Okay, do you guys understand why he's solving for y? He's putting it in slope-intercept form. You guys understand that? So you have 3y equals what, Owen?
I said that 3y equals negative 2x
Yep.
minus 3.
Okay, good. And then what are you going to do next?
Then I did the division property.
Yep, and you don't have to write it on this. Okay, I won't. Yep. Okay.
And then I did all by 3.
So y equals what?
Y equals negative 2/3 x minus 1.
Okay.
And then I said that the slope was 3/2, and I said that it was because of the definition of perpendicular.
Very good definition. So really, guys, all we're going to do is cannibalize this equation. We only care about the slope. Okay, we don't care about the y-intercept. That's another equation. We don't want that. We want the slope. So we take that slope and then we'd use the definition. I like how Owen said that. So and here's how I like to write perpendicular slope. This is my perpendicular. What letter do we use for slope, guys? M. And what is the perpendicular M, Owen? 3/2. You change the sign and flip the fraction. You guys understand that? That's the perpendicular slope rule, right, guys? And that would be your answer right there. Okay, we good? Any questions? Okay, all right. So let's see if we can use that information to write an equation. So the next one is, what is the equation? What is this? 9. Ben, do you have a special way you want to number this, or?
This is going to be called
Number 9. Okay, all right, pretty easy. All right, number 9. What is the equation of a line that passes through 2, negative 3, and is perpendicular to the line 2x plus 5y equals 10? And there's different ways you can write a line, but I want the final answer in slope-intercept form.
And we don't have to write down the reasons for this.
No reasons necessary. Okay, does that sound good, guys? Yeah, I won't make you write the reasons on. I probably will only make you write the reasons on one transversal problem. Sound good? I will make you write the reasons on a transversal problem. Okay? All right. I would say, Ben, how many kids do you think we should call on this? This is probably at least a 2-kidder, right? So first of all, Ben, we got to do either victim, stick, or what's the other one? Volunteer.
Mr. Boston.
Boston. All right, Mr. Boston. So that whole reciprocal flip thing's good, right, Boston? So Boston, we need to get this thing in slope intercept form, right? And slope intercept form, Boston, means solve for y. So we have 2x plus 5y equals 10. So Boston, I'm helping you out a little bit here. Is that right? How do you solve this one for y, Boston? Okay, you guys understand that? So if we subtract 2x from both sides, we get 5y equals what, Boston? Good. Now, Boston, are we done yet? Okay. So what's next?
You're going to divide each side by 5.
Divide everything by 5. Does everyone understand that? So what's your equation in slope-intercept form, Boston?
So it'd be y equals negative 2 over 5.
Yep.
X plus 2.
Okay, very good. Now, Boston, you're almost done. What's the slope of this line right here?
It's going to be
Oh, sorry.
negative 2.
Right, that's the slope of this line. So that's the slope. So what would be the perpendicular slope, Boston?
It would be 5 over 2.
That would be 5 over 2. We flip it and change the sign. Does everyone understand that? Very nice job, Boston. Okay, we're not done yet. So now remember, guys, we're writing an equation. This one is actually requiring an equation. So Ben, volunteer, victim, or stick? Connor. What would we go next, Connor? Okay, so into the equation y equals mx plus b? Okay, and you could also use, I think it was Aaron, like point slope, and that's fine, okay? If you want it, you could either put it in here or you can put it in what we call point slope. Okay, either one's fine. Point slope is actually pretty cool, but we'll do slope intercept. Either one of these equations are fine. You guys understand this? This is slope intercept, right, guys? Don't worry, I yell all the time too, so I'm glad she's yelling. And this is point slope. You guys understand that? You guys see that? Those two. So Aaron likes that whole point slope, but I'm suggesting maybe slope intercept. Does that sound good, Connor? So instead of a y, what are you going to temporarily replace the y with? Negative 3. You guys see this is the x value and this is the y value. You guys see that? Equals, what's the m that we figured out? 5 over 2. And then what's the x value? Yep, in parentheses 2. Can I call it 2 over 1 if I want? Plus, we need to find b, right? Okay, so what's next? And what's 10 halves reduced to? So this is negative 3 equals 5 plus b. Is that what you're saying, Connor? What's next? Okay, and so what is negative 3 minus 5? So b equals negative 8. Okay, good job, Connor. You did well. So now, we're not done yet. So now we have to get our final equation here. We've got our information, right? So now we need to write our equation. And Ben, volunteer, stick, or victim?
I am going to let
Fancy Aaron. All right, Fancy Aaron. What do you got?
So the equation would be y equals 5 halves x minus 8.
There you go. Okay. Notice, guys, once we figure out this slope here, we just cannibalize it and get rid of all that other stuff. Do you guys understand that? Cannibalizing means we just take it, rip it out of the equation, and then throw all that other stuff away. We don't want it. You guys understand that? Questions, concerns, or comments? All right. Look, go ahead and what box are we on, class? Oh, this is it, number 10. All right. So number 10. Here we go.
I'd like to let anyone who is feeling like a stretch break. I think this problem feels pretty hefty. I think they should be allowed one brisk walk around the building.
Okay, ladies and gentlemen, everyone stand up. Okay, here's the rule. Here's the rule. Brisk walk, 2 laps, no talking. Now, I'm not supposed to let kids out in the hallway right now, but I'm going to break the rule. Don't break. Brisk walk, 2 laps, no talking. If you need it, but if you go out in the hall, you have to follow the rules. If you don't need it, you can just stay in the room. If you go out in the hall, you need to do a brisk walk, no running, 2 laps, stay on the right side, come back. You guys got it? Is that fair? Okay, go. No talking. If you don't need it, great.
Can we stand next to the fridge?
Sure, as long as you don't talk. No brisk walk. Only 2 laps, guys.
Just did 2 laps.
Huh?
How do you get about it?
Yeah, but now I'm not the problem solver.
They're supposed to be.
Oh, yeah, okay. Is there a tie?
No.
All right, y'all, we're good. All right. Ben, I think that was a good idea. Oh, did we lose Steven? No, my goodness.
I hope everyone is feeling refreshed, fresh, and ready to do some math. Possibly.
All right, ladies and gentlemen, welcome back to. You guys feel like you're more refreshed now?
Yes.
Okay. All right, here we go. You guys did a nice job. I didn't see anyone like doing bad things, so good job. Okay. All right. So now, this one, I probably go ahead and write the problem down. Okay. Go ahead and write the problem down. All right, so go ahead. While you're writing the problem down, I am going to add. There's a couple more I want to do. So, anyways, so you guys are writing the problem down.
Mr. Roden.
Yeehaw.
Almost burst out laughing at least 5 times.
But you didn't. Nice job.
We got some really weird looks. Yeah. They were like, what are they all? One person thought it was a protest.
Yeah, they probably did. It looked like you were in a cult.
A math cult.
Mr. Roden, I have a question.
Yes.
Why, like, in this specific problem and a bunch of other things, it refers to lines and line segments as like twos, and
I don't know.
that's
Yeah, the twos are weird, huh? All right, y'all.
Mr. Roden. Do you have any candy I can have?
He override his will and let me do it because he has never chosen me, even when I raise my hand.
I will choose on you, Michael, when I feel the time is right.
I am
I'm gonna hold off on my grand decision yet. Do you feel pretty confident about this?
I made it. I'm raising my hand every single one.
You want to take a vote on it?
I'm gonna pull a stick.
Okay. I've got to respect the student of the day. I can't. I gotta. I try not. Michael, and that's amazing. Your stick got pulled, Michael. All right, Michael. Here we go. So, Michael, we need a perpendicular bisector, right? Now, if I just had to draw a little sketchy sketch here, right? That's embarrassing. All right, so if I had to draw a little sketchy sketch here, all right, 8, 4, negative 8, 4, that would be like something like maybe like here, right? And then 2, negative 2, that would be something like here, right, guys? Am I right? So we're looking at kind of just a segment like, I mean, I'm just estimating where this would be. I don't think we have to graph it, but just knowing that it would be something like that, right? So we want a perpendicular bisector. So in general, what a perpendicular bisector is, class, is it's just basically a line that splits it in half and is right. Something like that, right, guys? I don't know if that's a good sketch or not. Let's see if my sketch was any good. So I don't know. We'll see what happens. All right. So how are we going to do this, Michael? So we have this segment right here. We'll call it AB, right? And we need to find the midpoint of AB, and that's going to give us where that point goes through, right, Michael? Okay. So how are we going to do that? Yep. Huh? Okay. And now we're going to put numbers in, right? Negative 2 plus 4 over what? Huh? Over 2, comma.
2 plus negative 8.
Okay. Over what? Over 2. All right.
And then you simplify, and I got negative 3 over, or not negative, no, I got negative 3 comma 1.
You guys agree with that? What's negative 2 plus 4?
Oh, I mixed it up.
He said that
Ooh, Connor. I mixed it up.
bad.
I mixed it up.
Michael, your rights have been stripped.
It's the way I wrote it. I got the correct answer.
So what's the answer?
The answer is
What?
negative 3 comma 1.
Okay, so what's negative 2 plus 4? What's negative 2 plus 4? Divided by 2 is what? 1. So the midpoint is 1, comma. What's 2 plus? Am I right? Well, okay. Well, what did you mess up? Well, let's see these numbers. Negative 2 is, oh, you put y's there. I see what you did wrong. I believed you, Michael. So give me new numbers, Michael. So what do you got?
All right, so 2 plus negative 8.
So 2 plus negative 8 over 2. And then comma what? Comma what?
Negative 2 plus 4 over 2.
You guys agree with that? Negative 2 plus 4 over 8. Does everyone see what we're doing here, class? Are there any questions with what Michael's doing?
Wait, why over 8?
Sorry. Why over 8, Michael?
I said over 2.
Oh, he did. Okay. All right. So, Michael, in the end, this got a little mess. So what do you get, Michael? Okay. Do we all agree that's going to be negative 3 comma 1? Is that okay, guys? So we know that negative 3 comma 1 is the midpoint, which would make, that looks pretty good. Does my point look pretty good right there, guys, on my drawing? Okay, now we want the equation, right, guys? Okay. How are we going to find the equation? Michael, you got us off to a really good start. We found the midpoint, so how are we going to write the equation?
Well, you need to find the slope too.
You need to find the slope too, right? of the. So how would we find the slope of the between A B? How would we find the slope?
It's y2 minus y1 over x2 minus x1.
Okay. Does everyone see what Michael's saying here? Okay. We're finding the slope of line AB. This is the slope of segment AB, right, guys? And hopefully it's going to be a negative slope, right? Okay. So, Michael, what's y2?
-2.
What's y1?
4.
What's x2? What's x1? Okay. So, what's -2 minus 4, Michael? What's 2 minus -8? What's that? That's going to be what? 10. We reduce that. It's going to be what? If we simplify it, what's that going to be, Michael? -3/5. Okay. That's our slope of AB. You guys understand that? Okay. So now we need to write the equation of the line that goes through this point M, which is the midpoint, and has a perpendicular slope to AB. So Ben, I think it's time for another stick. Is that right? Or whatever you want to do.
It is myself.
Okay, Ben, what do we do next?
Okay, so we need. So we're gonna take the. I'm gonna do this in slope intercept form.
Okay, so y equals mx plus b.
Yes.
Okay.
Y is going to equal the number 1.
And that's from the midpoint, right?
Right.
Equals.
It is going then we will insert 5/3.
Okay, why? Why are we inserting 5/3?
Because that would be the perpendicular slope.
Perpendicular slope. Very good, Ben. Yep. Yep.
X will be -3.
Yep. And what?
Plus B.
Plus b. Does everyone see that? Okay, can you simplify that 5/3 times -3? What would that be, Ben?
That will be -5.
So 1 equals, you guys see why that's -5 right there? Because the 3's cancel. Plus b, right, Ben? What's next?
Then we will add 5 to both sides.
Yep. Okay, see that? So b equals what?
B equals 6.
B equals 6. Okay, so we know b equals 6. What's our perpendicular slope, Ben?
Negative or 5/3.
Positive 5/3. Okay, so what's your equation, Ben? And if you want to say it or call on someone, I don't care.
Y equals 5/3x plus 6.
You guys see that? Does that make sense, guys? Okay. All right. Any questions? Owen.
Can I go fill up my water?
Ben, is that okay? No. Yeah, you can. Oh, okay. All right. All right, ladies and gentlemen, what box are we in? 11. All right. Figure out the value of x. On this one, I actually do want you to do a statement reason on it. Sorry, I lied before. I apologize, but I do want a statement reason. And all I want to know the length of FG.
Can I hear my sports?
Because she's teaching.
Oh.
A new equation.
Oh.
Wait, what's the rest of the equation? I only see FG. No.
Yeah, please do.
For tomorrow, you look like a dragon. Okay? Ew. But you did that one on your teacher's right little bit small little number line. Then
Okay, here we go.
choose all that applies. Choose all that applies.
Ben, what are we gonna do on this?
I'm going to call on Mr. Grady.
All right, Mr. Grady. Okay, Grady, what is your first statement?
X plus 11 equals 3x plus 1.
X plus 11 equals 3x plus 1. Why?
Because of the
Angle bisector theorem. Now, here's my question, Grady. Why can you use the angle bisector theorem on this? What makes this possible?
Because the angle bisector is if a point lies on the bisector of the angle that is equidistant from the two sides of the angle.
Okay, so how do we know it lies on the angle bisector? There's two things there.
We know it is.
What is the angle bisector?
The angle bisector is.
Yeah, on that picture right there.
Is E to G.
EG, ray EG. Do we all agree? Ray EG. Why do we know ray EG is an angle bisector, Owen?
Because there's two little circly things.
Right. So they're saying that these two angles are congruent, and that is the definition. That's the definition of an angle bisector, right, guys? A segment, ray, or line that creates two congruent segments where it intersects, right, guys? Okay. Now, we don't. Okay, great. So it's an angle bisector. What else do we have to know before we can actually set those two equations equal? What else do we have to know? Okay, it's on the angle bisector, but how do we? That doesn't automatically say they're going to be equal. So we actually probably should put another reason here. Ben, you want to call on someone? You want to volunteer? Stick? What?
What are you laughing about, Michael?
Exactly, Michael. Not funny. Michael Davis.
All right, Michael. Now, Michael, why? What else do we need to know? It is, yes, we agree G is on the angle bisector, right?
Yeah.
But what else do we have to know before we can actually say those two are equal to each other? What's important there? Okay, why is it important to have these right angles here, class? Let me highlight them there. Class, why is it important these right angles are? It's very important that we have right angles. If we didn't have right angles, then we would not be able to do this. What's important about those? So, Ben, you can either pick someone, pull.
It is because if we know that those lines are perpendicular to, like, if GH is perpendicular to right GH,
Huh?
then we can know that if they're both perpendicular, then they're both congruent.
Okay, so what we want to make sure, guys, is those are true distances, right? You've got to make sure those are true distances. The angle bisector theorem says if a point is on the angle bisector, then their true distances are equal distance. You guys understand that? What is a true distance? What is a, Aaron, what's a true distance? It's the nearest, it's the shortest distance between the point and the line. And the shortest distance between the point and the line always creates a what, Aaron? A perpendicular right angle. Do you guys understand that? And I know I'm kind of being nitpicky here, guys, but if you didn't have that, this line could be longer than this line's way longer, right? So you could have lots of lines that connect G to F, E, F, but the perpendicular distance is what I call it. I don't know if people call it. That's the true distance, because the true distance is 90 degrees. You guys see that? You guys good with that? So now, so we should probably state something like F, G, and GH are true distances, right? Something like that. And why do we know they're true distances, class? Why? Why do we know that? Ben, why do we know that?
Because the right angle.
Because of right angles. They're perpendicular, right angles, right? I would, yep. I need you guys to know that. That's really important. Okay, I don't want you just to random, because in general, yeah, you could randomly say just put the two equations equal to each other because they look kind of equal to each other. It would probably be a pretty good guess that they're equal to each other, but you want to make sure exactly why, because they're on the perpendicular bisector and they're both true distances. That's the key there. You guys understand that? Okay, so now you could say 11 plus x plus 11 equals 3x plus 1. And now it just becomes brainless algebra. You guys understand that? And I'm not too concerned with simple algebra in here. I'm more concerned with you understand what you have and use it. Okay, so Ben, what would come next? Let's do some brainless algebra.
Okay, so you would subtract x from both sides.
Yeah, and so you get 11 equals what?
11. Grady, can you please move your thing? You would get 11 equals 2x plus 1.
Yeah, and what's the reason there?
The subtraction property of equality.
Yep. And then what's next?
You would subtract 1 from each side.
Sure. And then you'd get what?
10 equals 2x.
Yep, and that's just, again, subtraction property of equality, right? Okay, and what's next?
And then you would divide both sides by 2.
So you get x equals what?
X would equal 5.
Yep, and then what is that?
This is the division property.
Yep. Okay, see that? And so now that you know x equals 5, so if someone said x equals 5, I would probably give them half credit, 50%. Congratulations, you have an F plus, okay? Nice job. You guys like F pluses? No. So how can we go from an F plus to an A plus? Ben, you want to pull a stick on that or whatever?
Okay. Aaron with an E.
Aaron with an E. How can you go from an F plus to an A plus on this, Aaron with an E?
Well, I think you have to get an extra 4 inside.
What's that?
An extra 4 inside. It's into an A minus though, so you might have to get 50%. I don't know, I'm lost.
X equals 5. Why is that not the complete answer?
X equals 5 because if we, I don't know, I'm completely lost.
So what is the question asking for?
The distance between F and G.
And is it 5?
Yes. No. Oh wait, X equals 11. Sorry, do it again.
So Aaron, how do you get from an F plus, which is 50%, to an A plus? What do you have to do?
5 in for X.
Yeah, you got to supplement 5 in for X. You guys see that? So F to G, guys, we're trying to find FG, right? So all you do is just put 5 in for X. You guys see that? So what is FG is equal to what, class? 5 plus 11. And what's that, guys? 16. That's substitution. There you go. FG does not have a, and why is that good that it does not have a line above it? Because you're finding the distance, right? No line is distance, and a line is actually the segment itself. All right, ladies and gentlemen, I need you guys to. Sorry, I need to text my wife. Guys, I want you guys to start the chain. Go. Starts with Colson. Start the chain. No, who starts it? Grady, start. Go.
Oh, wait, remember to tell. No, who are you telling? Okay, remember to
Go.
Austin, remember to tell Riley that we're supposed to tell the person
remember to tell the one person about the thing.
Well, remember to tell the person about the thing.
Michael, remember to tell that person about the thing.
Oh, yeah. Eric.
Stop filming, Mr. Rowdy.
Oh yeah, gotta stop filming.
Oh my god, yeah, right.